Good day, everyone. Welcome back to Shegun Tech Academy. And for those who are joining us for the first time on this platform, we talk about courses, subjects that we find hard to study and make sure we tackle them together. So, getting into the business of the day, today we are going to talk about current and resistance as it is written above. So, firstly, we are going to discuss about current, then we move on to resistance. So let us first know what is current. Current now is the rate at which an electric charge flows through a conductor or a circuit. So the current is the rate at which an electric charge flows through a conductor or a circuit. It is represented by the formula I equals to Q all over T. So now our I, which stands for current, and the Q standing for charge, and then our T standing for time. Our current is represented in ampere. So the unit for current is ampere. While the unit for charge is coulomb. And the unit for time is seconds. Yes. So this is just a mathematical expression of what current is. We have our I equals to Q over T. So let's take some easy questions on current before we go on to complex questions. So now let's take questions on current. Number one question we have: if 10C of charge passes through a wire in 2 seconds, what is This is a very easy question on current, and to solve this, we'll take use of the formula that we discussed earlier, which is I equals to Q all over T. So now, I already told us earlier that our charge is represented in coulomb, which is C. So we can note that our 10 here is representing our charge. So, and we are looking for our current is I. So we have I equals to our 10C, that is number the 10. Then our seconds is 2 seconds, which is also representing our time. So we have 2. So that is 10 divided by 2 is 5. So we must not forget our units. Our SI unit is very important when we are solving questions because removing them from our answer renders it valueless. So we are going to put our SI unit and mix it 5A. So that is just a simple question on current. So let's take another question on current. We have the current of 3 ampere flows for 10 seconds. How much charge has passed? So this is another tricky question on current, because in this question we are not asking for current directly. We are already giving our current to be 3 ampere, represented by the unit ampere there, and we have our time. So what we are lacking is the charge, our Q. So if we have our formula initially to be I equals to Q over T, and we have our I, we have our T, what we're looking for is our charge. So then we have to make our Q the subject of the formula. So if we do this all over one and cross multiply, we have our Q to be I times T. So that will be the formula to solve this particular question. So let's substitute in our mind. We will have Q equals to 3 times 10. So we have our Q to be 30. And let's not forget our SI unit C. So that means our Q will be 30 C. So these are simple questions to be solved on current. So let's move on to resistance, and then we're doing some questions that are related to both topics. So now moving on to resistance. Resistance is opposition. The material refers to the flow of electric current, and is represented by R equals to V over I. So now going by this definition, we have the resistance is the opposition that a material offers to the flow of electric current. So initially we have that current is the rate of charge that goes through a conductor, and then we have now the resistance is the opposition that a material offers to the flow of electric current, which means that a resistance is the tool or the method used to stop an electric current from passing through a chamber or a passage. So now we have our formula to the resistance, which is equals to volts, that's our voltage, and our I, which is current, and our R is resistance. So this is the mathematical representation of the term resistance, and it is represented by the SI unit ohms, which is also written as this. So this is the ohms representation, and that is the unit for resistance. So let's take a few questions of resistance, then move on to some complex questions. So now we have questions on resistance. So let's assume that to calculate resistance if the 12 volts battery produces a current of 4 ampere. So now to solve this, we'll go back to the formula that was shown to us earlier, which is our R equals to V over I, whereby this stands for voltage and this is our current. And initially we know that our current is represented by the sign ampere, and this is our 12 volts here, which means our resistance equation is complete. So we have resistance equals to V, which is 12, all over I, which is 4. So 12 divided by 4 is 3. So we have 3 ohms, which can also be represented by the sign of this. So these are the answer for the first question. So let's take another question on resistance. So we have a circuit as a resistance of 10 ohms, and the current of 2 ampere. What is the voltage? So now this question is a bit tricky because we already been given our resistance. We are not looking for resistance in this term. So that means this formula has to be changed. So initially we have our resistance to be volt over current. But now we have resistance and we have current. We are looking for our voltage. So we have to do the step we took in the question for current, which is cross multiplication, and make our volt the subject of the formula. So making that a solid number, we have V equals to R times I. So that is just our 10, which is for our resistance, times 2, which is our current. So we have 10 times 2, and that gives us 20 volts. So that is the answer for this particular question. So let's move on to some complex questions of current and resistance. Okay, now so here are some challenging questions on current and resistance. So right here we have in the circuit below a 18 volt source and a 4 ohms, a 6 ohms and an 8 ohm resistor form a single loop. The 6 ohm is between the source and the 4 ohm. The 8 ohm is between the source and the 4 ohm on the other side. Find the current through each resistor. So now we have already drawn a diagram to represent what this question was asking. So hereby we have our 4 ohms above, and then our 18 volt, which is the source for the main connection, and we have our 6 ohms and 8 ohms between each other for the resistor in the return. So now to solve this is very easy. All we have to do is to compute our total resistance together and to divide them by the voltage so we can get our current. Instead, we should find the current through each resistor. So now let's take our initial formula for resistance is R equals to V over I. Note that we're using the formula for current, despite the fact that we are asked to find current, simply because the entitlement of this question is entailing voltage and resistance. There is no voltage in the formula for current. It deals with charge and time. We're going to use the formula for resistance. So now we have our voltage over I. Meanwhile, we are looking for our I, which is current. So we are going to make our I subject of the formula. If you take this all over, we have I R equals to V, and then we divide both sides by the coefficient of I, which is R. R takes an R, and we have R here. So our I equals to V over R. So now putting that into this equation that we have above here, let's take out our total resistance. So total resistance equals to 4 plus 6 plus 8. That is going to give us 18 volts, 18 ohms. So now we have that our I equals to V over R. Initially our voltage is 18 and our resistance is also 18. So our I is going to be 18 all over 18. That is 1 ampere. So that is the final answer for this question, and I hope we get that. So move on to the second question here. We have 3 resistors, R1 which is at 2 ohms, R2 at 3 ohms, and R3 at 6 ohms. They are in parallel across a 12 volt supply. So we are asked to compute the total current drawn and the current through each resistors. This is also a very easy but tricky question. So to solve this now, we have to first calculate our total current drawn. So to take our total current drawn, we have to know the value for each resistor. For us to be able to compute the total current drawn, let's not forget that the question says they are in parallel across a 12 volt supply. So now that is going to be that it will be all over 1. So it's going to be 1 over R. That is our total resistance. So we have 1 over 2, 1 over 3 plus 1 over 6. So now this is going to be equals to 1, but let's compute that. If we take our highest common factor here, we have 6. 2 divided by 6 will give us 3. 3 times 1 is still 3. Plus 3 in 6 will give us 2. 2 times 1 will give us 2. 6 in 6 will give us 1, and 1 times 1 will still be 1. So we have 6 all over 6, and that is equals to 1. So our total resistance is equals to 1. So now that we found our total resistance, we have to compute it and put it back into our I to find the total current drawn. It's just like the formula that we used right here, which is I equals to V all over R. So the same formula that we apply here, if we have our I equals to V over R. Our R is 1 and our V here is also 12. So our I is equals to be 12 all over 1, and that is still going to be 12 ampere. So our total current drawn is 12 ampere. So now to find for the second part of the question, which says current through each resistor. We already have our current, which is 12, but to find the current that goes through each resistor, we have to divide the current by the particular resistor we are looking for. So for our R1, we are going to be having 12 all over 2. That's going to give us 6. That's going to give us 6 ampere. So that is the current that is going through our R1. Then for our R2, we are going to be having 12 divided by 3, and that is going to give us 4 ampere. So we have 4 ampere going through our second resistor. And for our last resistor, R3, it is going to be 12 divided by 6, and that will be 2 ampere going through our third resistor. So that is an easy way to tackle a very tricky question like this. So here is another complex number under current and resistance. So now this question says solve for the current in 2-loop circuit. The two previous questions we did was on the 1-loop circuit. So this is a 2-loop circuit question. Our loop A is 12 volts minus 4 ohms and our resistor of 2 ohms, and our loop B is 8 volts minus 6 ohms, also going back to our resistor of 2 ohms. So now let's represent that mathematically so we can be able to solve for the current in the 2-loop circuit. First of all, we have to take our value for our loop A, which will be equals to 12 equals to 4IA. Let's remember that we are solving for current, and our A, which is to differentiate between the loops, minus 2, which is our N resistor, and we have to subtract IA minus IB. So our loop A equals to 12, okay, this should be minus 12 minus 4A minus 2, and we shall remember that our IA minus IB. Therefore, our loop B now, we have 8 minus 6 IB, that's for our loop B, minus 2 IA minus IB. So bringing that out, now we have 12 equals to minus 4 IA minus 2 IA minus 2 IB, and then we have 8 equals to minus 6 IB minus 2 IB minus 2 IA. That is for our IA minus IB. Our difference is going to be our initial resistor as we have here because they are both sharing the 2 ohm resistors. So that's why they are both carrying an extra 2 behind them. So now to solve this out now, we will have -4 minus 2. That's going to give us -6. So our IA makes them common. So we can work that out and make this happen. So we have this should be equal to -6 IA minus 2 IB. Then for this, -2 IB minus 2 IB, that's going to give us -8 IB and -2 IA. So now bringing that out, we have 12 equals to -6 IB minus 2 IB and 8 equals to -8 IB minus 2 IA. Okay, so from now here, we use our substitution method. So let's take our equation 1. We have to isolate our IB so that we can be able to substitute it in our equation 2. So now let's take out this equation 12 equals to -6 IA minus 2 IB. So we take our -2 IB here and bring our 12 here. So taking it, the plus sign, the minus sign will seem to plus. So we have 2 IB equals to -6 IB minus 12. So dividing both sides by the coefficient of IB, we have -6 IB minus 12 all over 2. So this is the equation for our IB. So now we have to substitute this equation into our equation 2. So now putting that into our equation 2, we have 8 equals to -8 bracket of, remember that our IB is -6 IA minus 12 all over 2 minus 2 IA. So now after completing this equation, we need to get a value for our IA. So now we have 8. So now to simplify this, we have 2 here 1 and 2 here 4. So now we have -4 into bracket -6 IA minus 12 minus 2 IA. So now our -4 times -6 IA, we are going to have 24 IA, and -4 times -12 are going to be having plus 48 minus 2 IA. So now that is 24 IA minus 2 IA. They are like them, so we are going to be left with 22 IA plus 48. So we are going to be having 8 equals to 22 IA plus 48. So now collecting items and then remove our 48 over, we are going to be having 8 minus 48 equals to 22 IA. We are having 8 minus 48 equals to 22 IA. So now plus 8 minus 48 is going to give us -14 equals to 22 IA. So dividing both sides by the coefficient of IA, we have -14 divided by 22. So IA is equals to -1.81. So we have the value for our IA. Now to substitute this into our IB, so that will take our equation for IB here, or we go back to any of the equations. But let's just take this, which is already our equation 3. So we had IB equals to -6 IA minus 12 all over 2. So now substituting IA into this, we are going to have IB equals to -6 bracket open, minus 1.81 minus 12 all over 2. So IB, so minus 6 times minus 1.81 is going to give us 10.86 minus 12 all over 2. By calculator, we are going to have 4.86. So that is the value for our IB, and this is the value for our IA. Our IB equals to 4.86. So now, going back to our initial equation that says IA minus IB. So we are going to be having minus 1.81 minus 4.86. IA minus IB is going to give us minus 6.67. So this is the total current shared between the two resistors. As our question said below, says so for the current in the two loop circuit below, and they were both sharing the resistor. So the current shared for the two loops below A and the loop B is minus 6.67. So we have come to the end of our video for today. Today we discussed about current and resistance, treating many questions of current, resistance, and also combined questions on both courses. So if you have any question, don't forget to ask in the comment section below, and let's not also forget to like, share, and subscribe. Thank you.